Okay, we've got an equation. We're going to be using Newton-Raphson. First point on Newton-Raphson, well, always check your formula book. So your formula book looks like this. Okay, and here's your Newton-Raphson method here. Okay, so the first thing to check is that you've really got an f of x that equals 0, and then we're going to use this expression for the iteration. So in the question we're doing currently, okay, then I have already got an f of x that equals 0. So my f of x is going to equal, so this is part A, f of x is going to equal x to the power 5 minus 3x plus 1. And I need f dashed of x because that's in the Newton-Raphson formula. So this is an easy one to differentiate. X to the 5 differentiates to 5x to the 4 minus 3, and the plus 1 disappears. So the iteration is going to be xn plus 1 equals xn minus, and then the formula book says it's f of xn over f dashed of xn. So in this case, that is going to be xn minus fraction with f of xn on the top, xn to the power 5 minus 3xn plus 1, and on the bottom I'm going to get 5xn to the power 4 minus 3, and we know that x0 is 1, that's my starting value. So to work out x1, first time through it, I have to show the substitution. So I'm going to take my starting value of 1 minus 1 to the power of 5 minus 3 times 1 plus 1 all over 5 times 1 to the power of 4 minus 3. And this doesn't really call for a calculator. This is 1 minus a fraction with, well, on the top I'm going to have 1 minus 3 plus 1 is minus 1, and on the bottom 5 minus 3 is 2, so I'm going to get an answer of 1.5. Okay, now this is slightly weird because I know that the question isn't lying. The solution is between 0 and 1. I used 1 as a starting value, but my supposedly improved approximation is actually further away from the root than my original starting value was. So what on earth is going on? And we're asked to explain what's going on using the graph. I'm going to double underline this because that is my improvement, or my supposed improvement. Okay, so what's happened on the graph? Well, remember the way Newton-Raphson works is it takes your starting value, so here's my x0, which is 1, and it takes the point on the graph where that starting value, the value corresponding to that, the y value for that, in fact the bit of the graph corresponding to that bit, and it draws the tangent. So the tangent to the curve there would look something like this. And the x-axis, I need to extend that for this to make sense. So the x-axis, it will find this point here. So my x1, okay, will be, that looks about right, 1.5. Okay, so x1 following the tangent along. So the tangent leads to 1.5. Okay, which is further from the root. Okay, where's the root? Well, I'm solving f of x equals 0. Okay, so this was the point I was hoping to find. So why have I gone the wrong way? Okay, so we need a because. So why have I gone the wrong way? It's because the part of the graph that I've reached when I use my initial value is actually the wrong side. The gradient has actually swapped sign. So there's a turning point. There could be various kinds of misbehavior of the graph in between the solution you're wanting. Okay, so the Newton-Raphson method only works well when you're dealing, I mean, anywhere here, any starting value within that loop would work really well because the graph doesn't change gradient all that much. But here the gradient has changed radically. In fact, it's the wrong sign because the gradient is the opposite sign to the gradient near the root. So that would be my explanation. Okay, so what I firstly completed the diagram, showing my understanding that what Newton-Raphson does is it finds the point opposite the starting value and it uses the tangent at that point to get to the next attempt at the solution. Okay, and I've explained that that's gone wrong because the slope is actually completely wrong. It's even got the opposite sign to the slope I should have been using. So that will be an acceptable explanation. So there are two parts to this question. The first one, I had to check that I had an f of x that equaled 0. Putting equals 0 on this wouldn't be a bad thing. Okay, I set up the Newton-Raphson formula. I used it clearly and got to the answer. I've double underlined the answer I found. Okay, and then in the second part, we did everything we've just discussed in terms of drawing the diagram, showing the tangent, and explaining that it has the wrong gradient.